on the topic of hypothesis testing. Hypothesis is an educated guess regarding what should happen in a particular situation under certain conditions. A hypothesis test is a process that uses sample statistics to test a claim about the value of population parameter. Researchers in fields such as medicine, psychology, industry, business rely on hypothesis testing to make informed decisions about new medicines, treatments, and marketing strategies. How do we state a hypothesis? A statement about a population parameter is called a statistical hypothesis. To test a population parameter, you should carefully state a pair of hypotheses, one that presents the claim and the other that is a complement. When one of these hypotheses is false, the other must be true. Either hypothesis, the null or the alternative hypothesis, may represent the original claim. Definition: a null hypothesis, which is denoted by H sub 0, is a statistical hypothesis that contains a statement of equality, such as less than equal to, more than equal to. 2. The alternative hypothesis, which is denoted by H sub A, is the complement of the null hypothesis. It's a statement that must be true if null is false. It contains a statement of strict inequality, such as more than, not equal to, less than. So how do we convert keywords and help writing null and alternative hypothesis? Your goal, your job is to find keywords in the question and convert them into mathematical statement and decide which one is null and which one is alternative hypothesis for you. For example, if you see a set of keywords like greater than or equal to, at least, not less than, it means that your null hypothesis is given to you. In this case, we write H sub 0, mu or population mean is more than or equals to K. However, if another set of key is given to you in the question, less than, below, fewer than, it means that your alternative hypothesis is given in the question. H sub A saying that mu or the population mean is less than K. In the second category, you might see sets of keywords like this: less than or equal to, at most, not more than, which means that your null hypothesis is given in the question. You're going to, for example, write down H sub 0, saying that the population mean is less than or equals to K. However, if another set of keywords is given in the question, like greater than, above, more than, it means that your alternative hypothesis is given to you. Alternative hypothesis in this case says, hey, the population mean is more than K. And finally, in the last category, if you see keyword like equal to, is, exactly, it means that your null is given. You're going to write it down as mu is equal to K, and this is your null hypothesis. However, if you see keywords like not equal to, different from, not, it means that your alternative hypothesis is given in the question. So in each question, you have one of these, either null or the alternative, and you can easily write the other one. For example, here is the summary of what we just discussed. In this question, write the claim as a mathematical statement, state the null and alternative hypothesis. What is the claim? Number one, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. It's a common mistake for students that saying that, hey, we have a keyword at least. At least is not a keyword here. The claim, the proportion is 61%, can be written as P equals to 61%. Its complement says, well, it's not equal to 61%. So please pay attention here. We have is 61%, which represents the third category. In the third category, if you have a keyword equal to is exactly, it means that your null hypothesis is given to you. So you can basically write down the null hypothesis, and then writing alternative hypothesis is very easy because it's the complement or the opposite. So in this case, you're going to write down the null hypothesis saying that, guys, please be careful here. Instead of mu, you have to use P, which represents the proportion. The question is about the proportion. So use P instead. P or proportion is 61%. The alternative hypothesis saying that it's not, it means that it's either less than 61% or more than 61%. We can visualize this this way. H sub 0 or null hypothesis says the proportion is exactly 61%. Alternative says, no, it might be less than or more than 61%. Next question for you. A car dealership announces that the mean time for an oil change is less than 15 minutes. Less than. So less than 15 minutes, we look for the keyword. Less than, it means that you're dealing with the very first category. It means that the alternative hypothesis is given to us. The claim the mean is less than 15 minutes can be written as mu is less than 15 minutes. Its complement saying that no, it's at least 15 minutes. So because mu is more than equals to 15, contains the statement of equality, it becomes the null hypothesis. So the alternative hypothesis is basically your claim. H sub 0 or null saying that mu is more than equals to 15, and the claim says mu is less than 15, and it is your alternative hypothesis. And finally, let's take a look at this example. A company advertises that the mean life of its furnaces is more than 18 years. More than, greater than, this is this category, the second category. The alternative hypothesis is given to us, and it is the claim. The claim, the mean is more than 18 years, can be written as mu more than 18 years. The complement, mu is less than equals to 18 years. So this is the exact same situation that we're having here. So null hypothesis says mu is less than equals to 18 years. Alternative hypothesis saying that mu is more than 18 years, and it happens to be your claim. So now that we learned how to write the null and alternative hypothesis, we want to test our hypothesis. Let's go over some important terminologies. In a hypothesis test, the level of significance is your maximum allowable probability of making a type 1 error. It is denoted by alpha. The probability of a type 2 error is denoted by beta. Recall that for type 1 and type 2 error, a type 1 error happens if the null hypothesis is rejected when it is true. A type 2 error happens if the null hypothesis is not rejected when it is false. We can summarize them this way. The truthness of null hypothesis, it can be true or it can be false. And then we make decisions about the null hypothesis. If the null hypothesis is true and you do not reject the null hypothesis, it's a correct decision because null hypothesis is true. So you don't reject the null hypothesis. But if null hypothesis is false and you do not reject it, it's a type 2 error. Another decision can be rejecting the null hypothesis. If null hypothesis is true and you reject null hypothesis, it's called type 1 error. However, if null hypothesis is false and you reject the null hypothesis, this is a true and correct decision. In our next definition, we're going to talk about the p-value. If the null hypothesis is true, then a p-value or probability value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. Decision rule based on p-value. To use a p-value, To make a decision in a hypothesis test, we compare the p-value and alpha. If p-value is less than or equals to alpha, then you reject the null hypothesis. If p is more than alpha, then you say that you fail to reject the null hypothesis, or you basically support the null hypothesis. If the alternative hypothesis H sub A contains less than inequality symbol, then you have a left tail test. In that case, the p-value is the area on the left-hand side of standardized test statistic. So after finding the standardized test statistic, we can find the area to the left, and it is your p-value. So again, this is called left tail test. All depends on the behavior of your alternative hypothesis. If it's mu less than k or p less than k, it means that you have a left tail test. If the alternative hypothesis contains the greater than inequality symbol, then the hypothesis test is called a right tail test. So in this case, the p-value is located on the right-hand side of the graph. After finding the standardized test statistic, you're going to find the area to the right side of the standardized test statistic, and it's going to be your p-value. So again, all depends on the behavior of alternative hypothesis. If it includes more than, it means that you have a right tail test. And finally, if the alternative hypothesis includes not equal to, you have a two-tail test. It means that half of the p-value is on the left and the other half is on the right. After finding the standardized test statistic, you can find the area on the left, then multiply that by 2 to find the p-value. This is called a two-tail test. After stating the null and alternative hypotheses and specifying the level of significance, the next step in a hypothesis test is to obtain a random sample from the population and calculate the sample statistic like x bar, p hat, or s squared, which is your sample variance. These values are corresponding to the parameter in the population, like mu, population mean, p, population proportion, or sigma squared, which is population variance. This sample statistic is called test statistic. With the assumption that the null hypothesis is true, the test statistic is then converted to a standardized test statistic like z, t, or chi-squared. The standardized test statistic is used in making the decision about the null hypothesis. So in the table below, we summarize the population parameter, the test statistic, and the standardized test statistic. If the population parameter is population mean, you're going to use the mean of the sample and then convert that into z or t. If sigma is given, it's a z. If sigma is not given, it's a t. If population parameter is proportion, you're going to use sample proportion p hat, and then the standardized test statistic is z. If the population parameter is variance, then you're going to use the sample variance, and the standardized test statistic is chi-squared. Z-test for proportion P. A Z-test for proportion P is a statistical test for population proportion. The Z-test can be used when a binomial distribution is given such that the normality is met. The test statistic is the sample proportion or p hat, and the standardized test statistic is defined as p hat minus p divided by square root of pq divided by n. This is the standardized test statistic for population proportion or p. Now, what are the guidelines? How do we analyze the null and alternative hypothesis? Using a z-test for proportion p, first verify that the sampling distribution of p hat can be approximated by normal distribution, so the normality is met, or the sample size are large enough. State the claim mathematically and verbally. What is null, what is alternative, and what is your claim? Specify the level of significance or alpha. You can also find the critical values and find the rejection region, or use your standardized test statistic to find the p-value and compare p-value and alpha. Make a decision to reject or fail to reject the null hypothesis, and finally, interpret the decision in the context of the claim. So finally, we need to see, should we support the claim or reject the claim? Let's take a look at one example together. Mendel's genetic experiments. When Mendel conducted his experiment with peas, one such experiment resulted in offspring consisting of 428 peas with green pods. So this is an important piece of information, and 152 peas with yellow pods. According to Mendel's theory, 1/4 of the offspring peas should have yellow pods. Question says use a 5% significance level with a p-value method to test the claim that the proportion of peas with yellow pods is equal to 1/4 or 25%. So first of all, the sample size is 428 plus 152, which is 580. So this is your sample size. P hat, which is 152 divided by 580 gives you 0.262. Why we are using 152? Because the claim is the proportion of peas with the yellow pods is equal to 25%. So we're going to use a sample with yellow pods. The number of yellow pods is 152 out of how many? Out of 580 in your sample. So that's how you end up with 0.262 or 26.2%. Now, since the claim is the proportion is 1/4, we can write it as population proportion is 25%, which is exactly the same as 1/4, but in the context, you're going to convert that into decimal. The original claim is that the proportion of peas with yellow pods is equal to 1/4. So we can express this as the population proportion as 25% or 0.25. The alternative hypothesis saying that, hey, it's not, it might be more than 25% or less than 25%. So because P is not equal to 25% as an alternative hypothesis, it means that we have a two-tail test. So the null hypothesis says the population proportion is 1/4 or 25%. The alternative hypothesis says it's not, less than or more than. You have a two-tail test. Since you have a two-tail test, half of the p-value is on the left, the other half is on the right. The significance level is 5%. Now, what are we going to do? We're going to find the standardized test statistic. How? By punching everything into our formula. P hat is the one that we calculated, is 0.262. P is given in the question to us, 25% or 1/4. And then on the denominator, you have P times Q over N. Q is 1 minus P. And we get the Z value to be 0.67. 0.67 is positive value on the right-hand side. It's roughly 0.67. It's going to be roughly here. Now, on the opposite side, you have negative 0.67. So when you have negative 0.67 on the opposite side, using the table, a standardized normal distribution table, help us to calculate this area on the left-hand side and then multiply that by 2. So negative 0.6 and 0.07 has the intersection at 0.25, 143. So again, your Z value is 0.67. But on the left-hand side, because of symmetry, you can use the area on the left-hand side. Remember that the table has the area on the left-hand side. So negative 0.6, so 0.6, and then the rest of the digits, 0.07, gives you the area as 0.25, 147. So now, since you have a two-tail test, you have to multiply this area by 2. which is going to be 0.5028. So this is your p-value. Now let us make a decision. Because the p-value of 0.5028 is greater than the significance level of 5%, we fail to reject the null hypothesis, or we basically support the null hypothesis. We are supporting the hypothesis that the population proportion is 25%. We are supporting the claim that the proportion of peas with yellow pods is equal to 25%. What if you have two populations and you want to compare the proportions? In this case, you can use two sample z-test for the difference between proportions. In this section, you'll learn how to use a z-test to test the difference between two population proportions, P1 and P2, using a sample proportion from each population. If a claim is about two population parameters, P1 and P2, then some possible pairs of null and alternative hypotheses are listed as below. Null hypothesis says the population proportions are equal. Its opposite, they are not equal. Null hypothesis might say that the first population proportion is less than or equal to the second population proportion, and alternative hypothesis says no, the first population proportion is more than the second population proportion. And finally, the last category, the first population proportion is more than or equals to second population proportion. It's complement saying that P1 is less than P2. Please note that regardless of which hypothesis you're going to use, you always assume there is no difference between the population proportions. It means that P1 is equal to P2. Now, two sample z-test for the difference between proportions has the following steps. A two sample z-test is used to test the difference between two population proportions, P1 and P2. When these conditions are met, first of all, the samples are random, they are independent from each other. The quantities of N1 P bar and N2 P bar and N1 Q bar, N2 Q bar, they are at least 5. P bar is basically the pooled estimate or weighted estimate. We're going to talk about this later. The test statistic is the difference between sample proportions, and the standardized test statistic can be written as Z, which is the difference between sample proportions minus the difference between population proportions, but this guy is equal to 0, so you can just specify it as 0, divided by the square root of P bar Q bar times 1 over N1 plus 1 over N2. P bar is defined as, so you're going to take all the successes in the first sample, in the second sample, add them together and divide by the total sample size. And Q bar is 1 minus P bar. If the null hypothesis states that P1 is equal to P2, or P1 is less than equals to P2, or P1 is more than or equals to P2, then you have an equality possibility. That's how P1 minus P2 is equal to 0 in the test. Let us go over the guidelines and an example for you. Using a two sample z-test for the difference between proportions. First of all, verify the samples are random and they're independent from each other. 2, find the weighted estimate or pooled estimate of P1 and P2 and check the normality. And the weighted estimate or pooled estimate is x1 plus x2 divided by n1 plus n2. State the claim. Identify null alternative hypothesis, specify the level of significance. You can determine the critical values to find the rejection region, or you can basically find the standardized test statistic and find your p-value. The standardized test statistic is the difference between sample proportions minus the difference between population proportions, but remember that this guy is equal to 0, divided by square root of P bar Q bar times 1 over N1 plus 1 over N2. Then make a decision to reject or fail to reject the null hypothesis and interpret the decision in the context of the original claim. One example for you. Racial profiling is an example that we're going to discuss today. For the sample data listed in a table, use a 5% significance level to test the claim that the proportion of Black drivers stopped by the police is greater than the proportion of white drivers who are stopped. So this is the table and the summary of the table. In the first category, we have Black drivers. We take a sample of 200 of them, and the number of people who were stopped by police is 24. In the second category, we have white drivers. We get a sample of 1,400 of them, and it turns out 147 of them are stopped by police. So the very first sample proportion is 24 divided by 200, which gives you 12%. The second sample proportion is 147, the number of people who are stopped by police, divided by the total number of people in the sample, in the second sample, which is 1,400, gives you 10.5%. Now we're going to use p-value method to hypothesize the testing. The claim is the number of people who were stopped by the police in the first category is greater than the number of people who were stopped by the police in the second category. So P1 is more than P2 is the claim. It is your alternative hypothesis. So you can write the null hypothesis as the opposite. It's less than or equal to the second category. The alternative hypothesis is your claim, everyone, because it doesn't have any equality. You can write down the null that saying that, hey, P1 is less than equals to P2, or basically to make it a little bit shorter, P1 is P2, and alternative hypothesis says P1 is more than P2, which is the original claim. The significance level is 5%. The maximum allowable probability of type 1 error. Now let us go to the next step. What is P bar? P bar is the total number of people who were stopped by the police, 24 plus 147, divided by the sample sizes, which is 200 plus 1,400 gives you 0.106875. Now you can calculate Q bar and basically move on to the next step and find the standardized test statistic. This is equal to the difference between sample sizes minus the difference between population proportions. So difference between sample proportions minus the difference between population proportions and divided by the square root of P bar Q bar over N1 plus P bar Q bar divided by N2. This number is 0.64. Since you have a right tail test, P or p-value is the area on the right-hand side of your graph. So here you have 0.64. 0.64 is about here. You want to find the area on the right-hand side, and that is going to be your p. But using the standard normal distribution table, we can find the area on the left-hand side. So due to symmetry, you're going to use negative 0.64. For negative 0.64, negative 0.64 is roughly here. So we find the area to the left-hand side here, and it's exactly the same as the area on the right-hand side. So negative 0.6, and then you have 4. Let's take a look at this area. The area is about 26%. So you can say that the p-value is 0.26%, but the thing is that the p-value is very large. It's more than 5%. So what's the meaning of that? It means that we fail to reject the null hypothesis that P1 is equal to P2. It means that we need to gather more information. So we are supporting the null hypothesis. When we say that, hey, we fail to reject the null hypothesis, it means that we're supporting the null hypothesis. So it means that we need to gather more information and analyze the data again. The definition of total variation distance. So in order to analyze two probability distributions and check to see if they are similar to each other, we can use the total variation distance. Basically, we are calculating the area between two probabilities and then finding the absolute value of those differences, add them together and divide by 2 to get the total variation distance. It has a nice formula. So suppose you have two probability distributions like P and Q. A straightforward formula specifying that the total variation distance between two distributions is a half of the summation of the absolute value of the difference between the probabilities. Px and Qx are the probabilities of an event like X under the two distributions P and Q. The absolute difference between these probabilities calculate how far apart the two probabilities are for each outcome X in the domain D. So as you can see, basically we are finding the difference between the Y values and finding the absolute value of them and add them together and divide by 2 the sum differences across all possible outcomes in the domain D. So we are basically using the domain for both of them. The factor I have is applied to ensure that the TVD is a value between 0 and 1, representing the minimal proportion of total probability mass that must be shifted to make the two distribution match. So this is a straightforward formula. In the next lecture, I gave you a very simple calculation. A more abstract formula